Now suppose I take cos x as 0, then cos x is 1, sin x is 0, again that gives me 0. So the only interval I can take values is this interval from minus pi by 2 to 0. If I take minus pi by 2, cos x is 0, sin x is minus 1, again this is so this inclusive of this. Now if I generalize this, I need to add 2n pi to that. So the solution is 2n pi. X should belong to this interval. So this is the solution. Okay. Now we had discussed that range. What is range? Range is the corresponding values that y can take for given values of x. Now let's find out what is the range of this function. What is the range? What are the values that y can take? You see that if I put any value in this interval, this is 0, this is 1, or in this, when this, I take x is 0, this is 1 and this is 0. Square root of that is 1, log of that is 1 by 1 is 0. So y is always 0. So this is the range of this function. Okay, so we had seen what domain of a function is, how to find the domain of a function. Now let's look at how to find the range of a function. If I have a function y equal to fx, then range is what values y will take. That is how range of a function is defined. Now to find range of a function, there is no hard and fast rule as such. What strategy we follow generally, not always, is that we write, if I am given y in terms of x, I first write x in terms of y. Let's say I write this, and then we find out what all values y can take to find the range y. Okay, let's say I give you a question like I have to find the range of the function this function x minus box of x divided by 1 plus x minus box of x. To find the range of this, I can write this, x minus box is fractional part. Look at this. Now let's follow the same strategy. 1 by y is what? 1 by y will be 1 by plus 1, or I can write 1 by fractional part of y as this, or fractional part of y is 1 minus y. So I have represented, I had been given y in terms of x, I have somehow represented x in terms of y. Now I need to find out what all values y can take. So I'll use the property of the fractional part. The fractional part I know lies between 0 and 1. So y by 1 minus y should lie between 0 and 1. Okay. Now, or I can say that y should be less than, okay, from this I'll get the expression as y greater than equal to 0. From here I'll get y less than half. So y should lie between 0 and half. I was asked to find the values that y can take. I have found out the values which y can take. So the values which y can take is this. So the range of the function fx is this. Okay. So we have seen what domain and range of a function is. Now we discuss the next very important term, which is composite functions. So now we'll study what a composite function is. Let's say I have a function. I have two sets, x, y, and I have set z. Okay, there's a function which relates x to y, so I get fx, and there's again a function g which takes the images of x as its domain. Suppose I have three images as 1, 2, 3. Now these three images becomes the domain of g, and I get some images here as 1 dash, 2 dash, and 3 dash. So if x, this is fx, and this one is g of fx. Okay. So what we have done is we have taken the f image of x to get g, then we take the g image of fx to find g of fx. I found out first fx, and then we found out g of fx. So you can directly write this as some rule h as g of f of x, or we write it as also g of f. Then this is known as the composite functions, because we are taking first one function, then we are applying again a rule which is g, and then we are finding g of fx to finally get h. So this is what a function, composite function, is defined. Now you can see that whatever was the range of fx is now the domain of g, and we get some different range of h. To make this more clear, to make composite function more clear, we'll solve some problems using composite functions, like how to find the domain and range of a composite function. Remember, finally when you are asked to find the domain of a composite function, you need to find out the values of x. You know that the domain of the composite function is fx, but you have to somehow express that in x. So you need to find out what values x can take. So this is how we will see when we solve some problems.